All right, welcome everybody to the last day of school. Technically, there's consultation hours this week in which I will be going over all of the topics that you've requested. One of the most requested topics was Python because I touched on it very lightly and deliberately, so this isn't a very hardcore programming class. But it was requested, so I will deliver. So in every programming language, there's only a few things you need to learn. And this kind of startles new computer science people or people that have never done computer science, is that there's only a few things you actually kind of need to know when you learn a new programming language. And experienced computer science people are just like, oh, I need to learn a new language? Okay, sometimes there's some tricky bits with like mindset and like how different programming languages approach programming, but in general, there's only like 5 or 6 different things you need to learn. And so you can, after you've learned enough, you can kind of pick up a new programming language in like a day or so. Like it's literally not that big a deal. And so the 5 or 6 things would be like variables, like how do you make a variable? How do you hold a value? It's like in algebra, right? X equals 5. How do you do that in this particular programming language? You also usually need to know how to do input and output, at least pretty quickly, because otherwise your program will just run this. You can't print anything to the screen, and your program will run the same every time if there's no input. So we'll go over how to do each of these things, by the way, in Python today. So variables, input and output, what we call conditionals or branches or if-else statements. There's a lot of different names for it, but basically having your code do different things. So if the temperature is over 80, turn the fan on. If the temperature is under 60, turn the heat on. Something like that. If then. That's where all of the intelligence in a program comes from. All of the intelligence in a program comes from conditionals. If this, then this. Or if not this, then this. Or if this is greater than this, then this. And so that's the brains of your program right there. Loops. Doing something multiple times. Until we reach the end of the file, read another number, that kind of stuff. For each person on the server, send them a message saying the server is going down in 5 minutes. Those are loops. So doing something repeatedly. And this is something that computers are great at and humans are not great at. So this is what separates, humans are better at conditionals. Humans are better at the brains stuff. Computers are better at the tedious repetition of things. Write on the chalkboard 100 times, something. Humans don't like that very much. Functions, like in algebra, how you have a function f of x is equal to 2 times x, something like that. You can really think of this as just like reusable code. Do something multiple times. That's basically about it. Then we might add in something like some sort of like data structure or something like that. Hold lots of variables. Maybe lump that into bullet point 1. Maybe we'll get rid of that. Variable, one variable, or multiple variables. Yeah. And then maybe you can add something called like classes and stuff like that, but I'm not going to worry about that for now. So we'll just say these 5 things here. Okay, that's all you really need to know to write any program in the world. And you might be like, that's deceptively simple. And yeah, it is. It's, becoming a good programmer is not really about learning these 5 things. It's learning about how to break a problem down, critical thinking. Okay, we need to do this. It's a big problem. Okay, so I need to split it into these parts. I'm going to solve this part first and then test it and then do this part next. That's really where the skill and experience in computer science comes from, not really from learning, the basics of a language. But today we're going to go over the basics of the language. So just from the top, we will do this. So there is a website that I like called Python Tutor. And if you go to pythontutor.com, we'll put a link into the chat if you want to follow along. And basically you can just click Start Visualizing Your Code Now. And we'll just take it from the top. How do you make a variable in Python? Well, it's pretty easy. You can just say like Bob equals 5, and then that makes a variable called Bob, and it is set to 5. There you go. There's variables. You can also set Bob equal to hello world, and then Bob now holds a string. A string is computer science jargon for words, multiple letters, 0 or more letters if you want to be precise. And in Python, it is not a strictly typed language, which means that it can go from being an integer in one line to being a string on the next. In languages like C++, things like that, you would have to say integer Bob equals 5. And then C++ will get mad at you if you try doing this. You have to specify what the type is. Now to do input and output, output works like this. You just say print, and you print the variable to print. And then you can hit visualize the execution. And this is what's kind of neat about Python Tuner. If you hit next, it runs that line of code. So now we see over here, we have a variable named Bob, and Bob's value is 5. We hit next. Bob's value is now hello world, because we just changed it from an integer to a string. And then we print Bob, and you see here's the output over here, and it prints hello world, and then the code is done running. And so you can go backwards, you go forwards, you can go to the first, you can go to the last, and you can view all of the variables that exist as you write your code. And then you just go back to edit the code and continue on. Okay. If you want to input the value of Bob, you can say Bob is equal to input, like that. And then Bob is 5, Bob is hello world. Now we are going to input Python is easy to learn. And you can see here Bob's value is Python is easy to learn, and it prints Python is easy to learn. There you go. So, yeah. That's the first two things. We haven't done multiple variables, so maybe there's one more thing that we could do. So numbers is equal to an empty list. And then we could read Bob in from the keyboard, and we could say nums.append Bob. Now we're getting into more advanced stuff here. And then print nums. Let's see how that works. Okay. So we read in some text. We append that to the end of the list. We print the list, and there you go. You can see that our word is now in the list. What is a list? A list is just a bunch of variables glued together. So if you want to hold more than one variable, you can make a list like this, and you can just keep appending things to it. So we could copy and paste this line of code a couple times. That. So we're going to read 4 numbers in, and then each time we read a number in, we add it to the end of the list. So I'll type in apple and banana, and coconut. You don't have to type things in an alphabetical order. And then durian. And you see, as I type it in, so Bob's value right now is durian, but it hasn't been added to the list yet because it's about to run this line. So green is the line that just ran. So I just did the input. So Bob's current value is durian, and it's about to append to the end of nums. That's what the red means. It's about to do that. So I hit next, and you can see that durian is now at the end of our list of fruits here. And then when I say print the list of fruits, it goes apple, banana, coconut, durian. Boom, just like that. Now, you might say, well, this is getting kind of repetitive, isn't it? Like you're copying and pasting the code over and over again. And the answer is, yeah, it kind of is. So what we could do instead is do like for loop. So for I in range 4, let's say, this means 4 times do these 2 things. So now we're on to loops. We haven't done conditionals yet, but I had a bunch of repetitive code there. And a loop is a great way of eliminating repetitive code. And so what this says is for I in range 4. So this is a kind of a weird syntax that you might need to take a moment to look at. But what's going to happen is maybe this might help a little bit. The first time through the loop, I is going to be equal to 0. The next time through the loop, I is going to be equal to 1. See, I is 0. We print the value of 0. We then read in some text, go to the next, go to the next. I is now 1. Read some more text. I is now 2. The next, go to the next. I is now 3. And then it ends. Okay. So when you say for I in range 4, that means 4 times do something. Okay. And technically the value of I is not going to be 1 to 4, which a lot of people think. In computer science, we always start counting from 0. So when you say for I in range 4, that's going to give 0, 1, 2, 3. So it's going to run a total of 4 times. If you don't want to print the value of I, you don't have to. You just think of this as repeat 4 times. And then that will go back to edit the code. We don't need you anymore. I just did that so you can kind of see what's going on. You don't need to do anything with I, in fact. This will just input 4 values, and each time it inputs a value, it adds it to the end of the list. And then it prints it once it's all done. So everything that's indented here is part of the list, and this thing is not part of the list. Or not part of the loop. So everything indented here is part of the loop. This thing is not indented, so it is not part of the loop. So it's going to do these 2 lines here 4 times, and then it will print the list. Yeah, so if you want to print, I don't know, what if we want to just take numbers, right? So you know how I said that variables have a type? So a type is like what kind of data it can hold. In Python, you sometimes want to be like, I only want numbers, right? Like I only want, I only want temperatures or something like that, right? Being able to type in durian isn't a temperature, right? And so you can do something like this instead. And int is short for integer. And so if we do this, watch what happens. So I can type in a number here, and it gets added to the list. And I can type in a number here, and it gets added to the list. And I can type in durian, and it crashes, which is good. Because we don't want to allow any stinky pineapples into our list of temperatures, right? Temperatures have to be a number. Like, it doesn't even make sense for... And I apologize if any of you are durian fans. I understand a lot of people like eating durian. But my lord, it does not smell good. So, yeah. And so basically, if you do this, facts. Yeah, thank you. Like, I've had durian ice cream before, and that wasn't bad. But like, if you go to a grocery store that has like durian like in it, you can smell the durian from like a ways away. So yeah, do you guys understand? So basically, if we do this, then we're saying, it's got to be an integer, right? And that's useful if you're like reading in rainfall data or temperature data or something like that. It'll kill your program which is good, because you don't want a low grade pineapple sitting in your list of numbers. So, so we know now by the time we get down here to line 6 that nums is all numbers because we only accept integers. So that's cool. So maybe we can do things like average it or something like that. So if you want to add up all the numbers in the list, we can do something called sum. So we're talking about functions now, actually. So we're going to call a function called sum, and sum will just add up all the numbers that we've entered. So if we do this, yeah, go away, I know why it didn't work. So if we add up 1 plus 2 plus 3 plus 4, then here's the list, 1, 2, 3, 4. The for loop ends, and then it's going to print the sum of all the numbers, 10. Okay. And so you might be like, but how do I know what functions exist in Python? And the answer is Google it. There's a candy that tastes good, smells awful. Yeah. In all seriousness, like if you wanna learn, like, how do I get the maximum number. Like maybe you're doing a little bit of statistics, right? You want to print the max value, the minimum value, the median value, that kind of stuff. Like literally it's like, I mean, you can guess, right? Like you could probably guess that in Python, getting the max values maybe called max, and you can just try it. You're not going to break anything. Like if the thing doesn't exist, 1, 10, negative 90, 9,000. Like it printed out 9,000, right? So you can sometimes guess, but most of the time you're just going to be like, how do I get a max value in Python, in list Python, right? And there's the max method, right? And you can click on, whatever. It'll have an example. They actually wrote max, which is, yeah, use the max function, please. Yeah. And so anyone want to take a guess how you get the minimum value of a bunch of numbers in Python? If you have a list of numbers in Python. Okay, anyone want to speculate wildly? But yeah, you honestly just Google it. If you could add them all together, and I don't know. Yeah. You can sort the list and then print the first element. I don't know. Yeah, no, it's min, right? I don't need to run this. Yeah, min. But like, yeah, you just Google things. And usually Python is so commonly searched for, like, how do I sort a list? And then you get Python, right? Because it's a very common thing. You click on that and you're like, all right, that's how you do it. All right, well, let's do that now, So nums.sort, right? So our list of numbers is called nums, call .sort on it. Okay, so we'll type in 10 and negative 20 and 420 and 9,001. And then when we call sort, watch what's about to happen. Okay, so we got 10, negative 20, 420, and then again in Python Tutor you can just click one line at a time and it will show you what happens when that line of code runs. Bloop. There, it's sorted now. Okay. Then when you print it, it comes out in sorted order. All right. And so, it's really funny. Like, I was doing a project with my daughter, and I'm telling her, like, all right, Ada, let me teach you the secret technique of programming. You're going to Google things, you're going to find code that does what you want, and you're going to copy it, and you're going to paste it, and then, make sure that, like in that last example there, like the variable name was different, right? And so you have to, like, you can't just copy and paste blindly, because if I did cars.sort, it's like, cars? What do you mean cars? Like, if I were to just kind of like paste this line in here, what happened there? Cars.sort. If I were to just do that, then it's like, never met this man in my life, And so you can't just like blindly copy stuff. Like you have to have like a certain amount of critical thinking and a certain amount of understanding what's happening to like make the copy pasting work. And then my wife yelled, like, you can't teach her to just copy and paste. That's not programming. And I'm like, well, there's a lot of that. It's not just copying and pasting, but there's a whole lot of Googling, how do I do X in whatever language you're programming in? And then you click on, a couple top links and you see if they're doing something similar to what you're trying to do. And you're like, there it is. It's called .sort. Okay, cool. Thank you. And then you move on with your life. And there's actually a negative review on Rate My Professor saying, the professor just told me to Google things. And, and I was teaching my C++ students Java, and I'm like, if you want to learn how to do something in Java that you know how to do in C++, you Google it, because that's literally what I did. I worked as a professional Java programmer for a couple years, and my background was in C++, and so I just dealt with it. Like you just go onto Google and search how do I do sort in Java, and it comes up. It's actually a really useful skill to have, and the student's like, no, you should teach us. And maybe there's some truth to that, but in all honesty, there's a lot of things you might want to do. I don't know what you're going to do. And so, becoming like a self-sufficient, person that can just kind of go out there and be like, oh, that's how it works. Okay. And then moving on with your life is actually a really useful skill to have. Okay, so we skipped over conditionals, so let's do that now. So let's say that we're only going to accept into our list of numbers temperatures, and so like, on Earth, what's the highest temperature there's been on Earth? I don't know. Like hottest, maybe like 137. I don't know. You don't want to take it's got to be like Death Valley or something, right? Death Valley, yeah. What's the hottest ever been? Hottest temperatures recorded. Highest temperature recorded on Earth. 134. Okay, yeah, that's pretty close. In Death Valley. All right. So if we ever get a number that's bigger than like 150, let's say that that's not valid. And if we get a number, what's the lowest? What's the lowest temperature? Yeah, it looks like a fun place to visit in the summertime. Lowest temperature recorded on Earth, negative 128 degrees in Antarctica. Wow. That does not look like a fun time right there. Is that like where the movie, like The Thing or something was filmed? I don't know. Okay. So, yeah, let's say negative 150 to positive 150. Okay. So now we're going to do conditionals. And so we're going to reject any data that's kind of outside of those bounds. And maybe we'll print a message or something like that. So in Python, you say if to do an if statement. And maybe let's not call it Bob anymore because we now know this is a temperature. Okay. So if the temperature is greater than 150, or if the temperature is less than negative 150, colon, and then it indents for you automatically. Indentation is how Python says what's part of the if statement. So if either of those is true, if either the temperature is too high or the temperature is too low, then everything that's indented here is part of the if block. So we're going to print error temperatures hopefully can't be that bad. Something like that. And then we will do a continue. Okay. And so what continue does is it jumps back up to the top of the loop and runs again. So it'll just basically say, no, sorry, try again, and then it's going to go back up here. And rather than using a for loop like this, we can use another kind of loop called a while loop. And we can say while true. So this is an infinite loop now. So basically this will run forever. And so you're like, all right, well, how do I get out of the infinite loop so we can get down here and move on with our life? Well, what if they entered like a special temperature code? Like if they entered print, please enter a temperature, or 9999 to quit. Something like that, right? So if they type in 9999, Inglourious Bastards reference, I don't know, might be too old for you guys. So so how can we do it? So people on chat, tell me, how can I say if the temperature equals 9999? Give me some code in the chat channel. How do I do that? How do I say if temperature equals 9999? Google it. Relying upon your help. Once more, what is it, the Bernie Sanders? Once more, I'm asking you to what's he gonna ask? Are you mad at me? Once again, I'm asking you to participate on Discord. There we go. Okay. If temperature equals, yeah, that's it. So if temperature double equals 9999, and then there's a colon. Don't forget the colon if you come from C++ or Java or something like that. You're used to curly braces. Python uses colon and indentation to accomplish the same goal. Yeah. So if temperature equals 9999, then we will break. And so break ends a loop. Yep. And so that's how you can get out of an infinite loop. So if they type in 9999, then it breaks and it comes down here and finishes. If they type in a temperature that's too big or too small, it says, no, sorry, try again. And otherwise, it will just add it to the list of numbers. So let's see how this goes. Go ahead. All right. While true, please enter temperature 999 or quit. So it prints that to the screen. We're going to type in 100 degrees. Obviously, we're using freedom units, not Fahrenheit, not Celsius, right? Not communism units. So, so if the temperature is over 150 or the temperature is less than negative 150, it's not. So it adds it to the list, right? So if the temperature was greater than 150, or if the temperature was less than negative 150, then it would have printed the error message, but it wasn't. It was okay. So we simply append it to the list, and we move on with our lives. If we type in 111, then it'll add that to the list. If we type in negative 100, it adds that to the list. If we type in 9,000, then it will say, is the temperature over 150? Yes, it is. So then it comes into here, prints out temperatures can't be that high, and jumps back up to the top. Okay. And then if we type in negative 9,000, then again it prints can't be that bad, jumps up to the top. And so you can keep building a program a little bit at a time in this way. And you basically want to always test your code, always write just a little bit of code at a time. One of the most common mistakes, and I have to emphasize this with all of my students, one of the biggest mistakes they try to make is just to try to copy and paste a giant block of code without understanding any of it, or they try writing all of this code without testing it, and then when they hit run, like just nothing works, and they're just like, I don't know what's going on. Whenever you're doing development, you should always make a couple lines and then test it and make sure that it works. I make mistakes all the time, especially switching between Python and C++. I'll use semicolons instead of colons or whatever. Just forget indentation issues and things like that. Like everyone makes mistakes. It's not a big deal. The main goal is to try to keep the complexity under control, so that if there's a problem, you know that it's in those last 2 or 3 lines you wrote. Like if I screwed this up, let me screw this up. So like if I said continue here, and I try running it, typing in some numbers, look, everything's working fine. It's vetting the numbers, everything's working. All right, cool. And then let's get out of here. 9999. Oh shoot, it didn't break, right? You need to test it and make sure that everything is going well and is working, and you can look at it in Python Tutor. You can look at it and see that the thing's working right. This code is so funny. What's funny about it? It's not at all the funniest code that I've written. So we also need to talk about else statements, I guess. So in Python, we could do else like that. It's not Elsa, that's the ice princess from Frozen. So else print, I don't know, temperature accepted. Okay. So if we type in 10, hit submit. If it's over 150 or below negative 150, we do this. It's not, so it goes to the else block. The else block runs if the if block does not. That's how conditionals work. Okay, so you have if, you have else, and then you have one more thing called else if. So elif temperature is over 100. We're going to print, wow, that's hot. You must live in Fresno. Okay. Elif, you have to undo the indentation. Elif temperature is less than, I don't know, 0. Print. Time to go skiing. Do you guys see this? And so what this is going to do, so you enter the temperature. If the temperature is 999, it quits out of the loop. If the temperature is too high or too low, we just reject it. Otherwise, we're going to print like a snarky message, based on the temperature, right? So the temperature is over 100. You say you must live in Fresno. If it's under 0, time to go skiing. Elif temperature equals 42. Don't forget the colon. Print the answer to life, the universe, everything. And you can keep doing this. Else, with a colon, print. I have nothing funny to say. Sorry. Okay. And so build up your code just a little bit at a time. We'll type in here 42. And so it's going to say, is 42 over 150? Nope. Is it under negative 150? Nope. Go on to the next one. Is 42 over 100? Nope. Go on to the next one. Is 42 under 0? Nope. Is 42 equal to 42? Yes, it is. So then it's going to print the answer to life, the universe, and everything. Bloop. And then it skips down to the end and adds it to the list. And do you guys see this tool? Like it's actually a really nice website that'll kind of show you everything that's going on. So if I type in 100, then that's within our acceptable range. 100 is not over 100, so it will just say I have nothing funny to say. Sorry. Adds 100 to the end of the list. We'll type in now 120, and now it's going to say, wow, that's hot. You must live in Fresno. And you can keep doing this over and over again. Negative 10, temperature is less than 0. Time to go skiing, right? Add it to the list. Now let's get out of here. 9999. Break. Sort the numbers. Bloop. Sorted. Print. There's our numbers. Good to go. And so a lot of computer science people break down computer science into 3 steps. Every program in 3 steps. I don't think it's actually true because I do video gaming, and video games don't actually follow this pattern, but a lot of computer science professors teach code this way. You have like an input phase where you're gathering data and maybe filtering data that's bad. If you're measuring the height of plants, you can't have a negative height, right? Like it just doesn't make sense. You discard it, or you kill the program, or you say, hey, that's an error, please enter it again, that kind of stuff. So you first do the input phase, you then do the analysis phase, where you do something with the data. And then you have the output phase. For example, if you're, I wrote for a couple $1,000, I wrote like an attendance system for a school district, and basically they had a bunch of workshops for their teachers, and they needed to track how many hours the teachers had put in. And if they got over 20 hours across the year in workshops, then they were given a check for like a couple $1,000. And so the way the thing worked was the people who were running the workshops would just dump the names of all the teachers into my website and then say this workshop was 8 hours. Bloop. And then it would go into a database. And they would do this all semester long, all year long. And at any point, they could say, get a report, and it would go and add together, it would find all the names, add together, this person, Raymar Barasaro, 5 hours here, Raymar Barasaro, 10 hours here, adds them together, gets 15, and then it prints it, then it sorts them all by hours. Anybody that was over the 20, the name would be in bold, Then below that it'd be not in bold. And so, they could send out reminders to teachers saying like, hey, you haven't, you're getting close to not meeting the 20-hour requirement. You should go to the next couple workshops, that kind of stuff. And so the output phase for that is very simple. I would just sort, in the analysis phase, I find everyone's names, find all the workshops they went to, added them together. Not that complicated. It was like not even a day's work for me. And then the output phase would be like generating a web page, and sorting it and putting it into a table and things like that. Here, our output phase is just, printing the numbers to the screen. So, what kind of analysis do you want to do? What's the average value? What's the, maximum value? What's the minimum value? What's the median value? What's, whatever kind of analysis that you need, you can basically Google it. Right? Like, I don't know, list methods. See if there's anything that matters here. Not really. So, yeah. And so basically that's kind of, if you want to think about like simple computer science programs, you feed in data to it, you do some sort of computation, and then you feed out data. And these things, like, this is a very generic pattern that a lot of programs follow. For example, you're working for Forever 21, and you're a programmer there, and so the input phase would be looking at the sales receipts for the past year, and then you do a ton of analysis on all of these sales receipts, and the output phase might be forecasting. We should buy more of this thing. We should buy less of this thing. Our stock levels are too high here. We should put them on sale. Our stock levels are too low. We should order more now before we sell out, that kind of stuff. And so that general idea is just found everywhere. In fact, they're probably doing it in Python. Like, I don't know. I know nothing about Forever 21, but the fact is you could do it in Python very easily. And Python's not as fast as C, C++, Java, things like that, but it's okay. It depends. It depends like on how much speed you actually need. If my attendance program ran whenever they clicked a button, and it didn't really matter if it ran in 10 seconds or 20 seconds. It ran fast, but like it didn't matter. And some of my bigger computations, which are running across hundreds of thousands of test data and things like that, like those would take like 15 minutes to run. But I only ran it once a year, so I didn't care. I would just go to Starbucks, hit run, go to Starbucks, get my coffee, come back. There's the answer. All right, thank you. Write up my report. Okay, so that's kind of, we didn't really do functions. Let's do a function. Okay, so define I don't know, password. What do you think? What should we do for the, what kind of function should we do? Or you just do like f of x or something. Something like that if you want. Return 2 times x. Like, you do something boring like that if you want. So every time we read in the temperature, we can, temperature is equal to f of temperature. I don't know. Doesn't seem very exciting to me. We're going to double the temperature. I don't know. So, but that's kind of what it looks like, right? So, x is equal to minus b or square root of b squared minus 4ac over... I'm not typing that. I'm not typing that. So this is the basic syntax. We're doing a function. So we have a function here named f. Of course it's f. It's math. We only use 1 letters for things. It takes in a parameter named x, and then it returns twice the value passed in. So if you do this, If you pass in 10 to it, it returns 20, right? So let's do this. So we'll type in 10, and you can see the temperature is 10 currently. We then go up to F. F has 10 passed to it, and then we return 20, and then it comes back down here, and temperature is 20. Okay, so I don't know, not very exciting, but you know, that's the basics of doing a function. And a function really is just reusable code. So if you're going to be doing something over and over again, if you're going to be doing these same 5 commands over and over again, like hypot, right? Like square root of, you know, x squared plus y squared square rooted, you know. If you do that, if you do something like that over and over again, then you put it into a function and you reuse the code. Okay. I don't know. It's basically it. Yeah. It's kind of everything. I'll put the function back up in here. There. You can kind of see what a function looks like. And you can do more than just math, right? Like you could say for I in range 10, print hello world. I don't know why you do this, but every time you would call f of x, it'll print hello world 10 times. I'm kind of scratching the bottom of the barrel here for ideas. I need better ideas from you all. What kinds of things do you want to see? And then it's going to start doing hello world, hello world, hello world, hello world, hello world, and then it returns 20. So, yeah, you can kind of have anything you want in a function, and you know, it's just every time you call that function like this, you do it with f and then parentheses like that. If it takes a parameter, you pass a parameter to it like that. It will pause your program, jump up here, do it a bunch of times, then go back. So if you're familiar with functions from algebra, you know, you should have kind of a general idea of what's going on here. So that's basically it. On Friday, we're going to be going over. I've been taking notes on all of the things you've requested for me to go over for the final review. So we'll do a final review on Friday during consultation days. For Python, your task is going to be to write code like this that will take in temperature data, let's say. Let's just stick with our theme here. We'll discard invalid temperature data, and we'll print out the maximum temperature, the minimum temperature, and the average temperature. And I think you should be able to do all of those because I've kind of shown how to do almost all of that. So you don't have to have any snarky comments or anything like that. You just have to write a program that's going to input a bunch of numbers until, let's say, they type in 9999 to quit. No. So basically pretty similar to what we have here. But at the end of it, I want you to do a little bit of analysis, print out the max value, the min value, the average value. We could do more, but this is CSI 1, so we're just keeping it simple. Okay, real, you know, very close to what we have on the screen here. You don't have to sort anything. You can get rid of that line. You don't need the function. You don't need any of the snarky comments. Okay, and so you'll just copy and paste the code on, or screenshot it or whatever onto Canvas, and then that's it. And if you are excited by programming, and or if you're not quite excited, but you're like, maybe this is something that I could do for a career, well, you know, take CSI 40. You know, CSI 40 is the first real computer science class. This class is a gentle introduction to programming and things like that. That said, you know, you did kind of learn everything in computer science in one day. So, you know, after this point, it's just practicing. So, and of course, you know, the most important skill of all in computer science is, Googling, right? So, plagiarism. But plagiarism doesn't work honestly if you don't have like basic critical thinking skills, because I've seen so many students like in other classes, like I'll say like, all right, I need you to do this, give me code for it, and they just like Google it and just copy and paste the first answer, and it does not do at all what I was asking for. And so I always write back to them, I'm like, if you're going to be copy and pasting code from Google, you need to make sure it's actually doing what you think it's doing, what I am asking for it to be doing. Because they'll just be like, oh, that's the first hit. There you go. 0. There you go. If you plagiarized successfully, you'd get it 100%, but you didn't. You plagiarized something completely wrong, and you didn't have the critical thinking skills. You didn't even have the computer science skills to know that what you copied and pasted is wrong. So, it's disappointing to me. Like, if you're going to plagiarize, at least plagiarize code that works. There are no classes on Friday. That is correct. It is consultation days. I will be doing a final review for my consultation hours on Friday. Okay. You do not. This is the last class. The last class participation is the time period between today and Friday. So the last thing you see on Discord is today. That's it. No more class participation. You're done. You don't have to show up on Friday. You don't have to participate if you know all the material. Just take it easy, whatever. But a lot of students have been asking me to do a consultation day thing on consultation day. So I'm going to be putting together a presentation that goes over the topics that were most requested on the last quiz. On the last quiz, I asked, what do you want me to go over again for the final? And I'm going to go over those things for the final during consultation hours on Friday. Okay? Same time. Yeah, same time. It'll be an hour. And if you have any other questions, I have office hours tomorrow 2 to 3:30, tomorrow 6 to 8 p.m., and then, anytime on Friday also. You can message me on Discord, of course. Although you can honestly do that anytime the whole semester, because I'm always on Discord. So that's it for today. Python in one day, basically. Just practice it. 4 years of practice, and then you'll be good to go. Nah, it's not 4 years. To get a junior developer position, it's about probably a year or two. Depends how many hours you put in, that kind of stuff. So yeah, thank you all for a great semester. I've really enjoyed teaching you all. It's been a bit weird with the online and everything, but we'll be back in person in fall. So awesome. So thank you all very much. I really appreciate it. Thank you for all the kind words too. All right, see you guys.